So now members, let us see what happens when we are given a sample population. How do you get the sample mean and then the sample variance? So let us get a quick go through here. As in sample populations, the number is very, in some populations the number is very high. This is very high or very big. And the calculation in statistics tend to be tedious. This calls for sampling of some elements of the population to be used in statistical calculations to estimate the population data. So now when the population is too big, like you can't work on everything, like maybe a country is having an population of 40 million. You can't get all of them and then you calculate that statistic data you want. What you do, you sample out some. If you find maybe a region is having over 200,000 people, you can use 1,000, you sample. So that sample we are using is what we are talking about here. So the unbiased estimator now here to estimate the population data. Now that estimation or the unbiased estimator that we are going to use in that or in those calculations, we need to know or what thing do we need to know about it. This is a sample statistic whose expectation is equal to that of the population. When you get that sample and then you calculate maybe the mean of that sample, that mean should be approximately equal to the mean of the whole population. So the most efficient unbiased estimator is one with the smallest variance, as we are going to see. So the mean of the sample population, the formula for the mean remains the same, it's given by that. Then the sample variance, or some people call this as the unbiased estimate of the population variance, is given by this. Now here I'm using S because we are dealing with the sample. N over n minus 1 dot sigma, this is S, x squared minus this. Or if we have frequency, this is the same way we get. Remember, our x bar is this in terms of frequency. If it's in terms of n, then it's like this. So this n, remember this n is the number of elements that we are dealing with. Always we can say it's the same as summation f. So the sample standard deviation, known as standard deviation, is the square root of the variance. And then the square root of this is what we get. Remember our x bar here, this x bar is this from here. Let us say an example there. So this formula, whenever you hear something about a sample and tell you to get the variance, don't forget that after calculating this, you multiply with that number, n over n minus 1, as simple as that. Let us go through this question. A sample of 20 students, now so they are using, maybe they are in a student class, out of 100, they sample out 20. Now when they tell you to get the variance of that they are giving you, you always don't forget to use that n over n minus 1. That's the only difference. So, heights, students of 20 students have the following heights. The sum of the students have the following heights in meters. Find the mean and variance and standard deviation for the data. So now, those with the heights are in meters. So 1.5, those with 1.5 meters, we have only 1. Those with 1.6, we have 3, 1.7, we have 10, 1.8, we have 5. And that one is having the longest or the tallest is having 2 meters. Now, what we do always, because we are dealing with the sample, we need to get these are our x. Now we take this as our x values. The frequency, the number of times it appears. So 1.5 meters is appearing once. 1.6 meters is appearing 3 times. 1.7, 10, then 1.85, then 2, 1. Then after we sum this, when we sum all these ones, we get 20. Then we need fx, because we need the formula I am going to use is this one here. So fx, we need the mean, so this times this, we get this. I mean, this time this we get this. This time this we get this. This time this up to when we reach here. Now, when we get to, we need also f of x squared. Meaning, this one, you first square x, then you multiply it with the frequency, then after we sum. That's what these formulas mean. So the formula, we need x squared. So when I square x, this is my x. When I square this, I get this. Square this, you get this. Square this, you get this. Square this, you get this. And square this, you get this. Then after, we multiply them with their frequency. So this times this, we get this. This times this, we get this. This times this, we get this. After we reach to this times this, we get that. Then after, we sum them. Now our formula for mean and variance, I'm already setting them there. Now we just going to substitute and we get the answer there. So our summation f of x is here 34.3 divided by 20. Then we see that we give that one for the small places. So 34 point. The answer I'm having is 1 point. This one is terminating. It's giving us a value which is that. So now this one is going to be our mean. Now our mean, you give the units is in also meters. Then after that, we come for the variance. Our variance, our n is the total of this, which we say from here. Our n is always equal to summation f. That's why here I'm having 20. Then 20 minus 1. Then summation fx squared is this over summation f, which is 20. Then subtract off the mean. Our mean here is 1.715, the whole now squared. Now, the question is, how do we place this on the calculator? What we do, this is what we do. You first place 29.03 divided by 20, as I'm doing 29.03. I'm showing you how you press this on the calculator. Divide by 20. You press equals. Now answer. You say answer minus. Now you open the brackets. You put this in value 1.715. You close brackets. Then you square. Then you press equals. Then answer, you get the square root. The answer of this, then you get the square root. So you say square root, then answer, you press equals. Then out here, then you say answer times 20. This 20 is multiplying, then you press equals. Divide by, now this one is going to be 20 minus 1, which is 19. Now divide by 19. And so, my variance there is going to be 0.1067. Then you think you can easily get the square root of that. So, that's how you press that. And so, I wish you well. Please don't forget to put the units. These are also in meters. So the variance of the height, that's how it's going to be. I think you can get the standard deviation there.